In 1997, AB 22, question asks, what are the values of x for which the function f, defined by f of x's quantity x squared minus 3 times e to the negative x, is increasing? So what we really want to find out is where f prime of x is greater than 0. The bottom line is that f of x increases when f prime of x is greater than 0. So we need to find the first derivative and find out where it is positive. So we start with the function x squared minus 3 quantity times e to the negative x. The basic structure of this derivative will be a product rule, and a product rule with a chain rule, at least in the second factor. So it's 1 d2, and the derivative of e to the negative x, the derivative of e to the whatever is e to the whatever times the derivative of whatever. Well, the derivative of negative x is going to be negative 1, so that will give us negative e to the negative x. So it's 1d2 plus 2d1, and the derivative of x squared minus 3 is simply 2x. So what I would do for this one, since the second term is positive, I would move that to the front, like so, and then we have negative. The second term is negative, so I would put minus. And so we have 2x e to the negative x minus quantity x squared minus 3 times e to the negative x. The next thing that I would do there is to factor out e to the negative x. And when I do that, that leaves 2x minus x squared plus 3. However, if we want to write that as a standard quadratic, I would have to factor out a negative 1 from that expression. When I do that, I end up with negative e to the negative x times x squared times the quantity x squared minus 2x minus 3. Now x squared minus 2x minus 3 can be factored, and that would leave us with negative e to the negative x times the quantity x minus 3 times the quantity x plus 1. We can see that the zeros of this function, since e to the negative x is never 0, e to the x, e to the negative x is never 0 unless you add or subtract 1 from one of those functions there. Add or subtract some quantity from the function to shift it down where it will cross the x-axis. Otherwise, it's never going to be negative. So our only zeros here will be x equals 3 and x equals negative 1. Now when we make the sign chart for this, you really have to be careful because of that negative out in the front of the whole expression. So I'm going to choose negative 1, 0, and 4 as my test values. And since we're trying to find out where f prime of x is positive, I'm going to plug those test values into the first derivative because I want to know the sign of the first derivative. So it's always best to plug them into the factored form if possible. So I'm going to plug in negative 2. I know that the negative sign is negative. Then e to the negative x is always positive, but negative times positive will make that first part of it always negative. Even though e to the negative x is always positive, when I make that negative, it's obviously going to be always negative. So I plug in x equals negative 2. X minus 3 will be negative, and x plus 1 will be negative. So I will have negative, 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 which makes that negative, or makes the first derivative negative in that interval. Next I plug in 0. Well, the first term, negative e to the negative x, is always negative. 0 minus 3 is negative, 0 plus 1 is positive, so I have negative, negative, positive, which will become positive. And finally, again, negative e to the negative x, always negative. 4 minus 3 is positive, 4 plus 1 is positive, so I have negative, positive, positive, which is negative. And so the question is, where is f of x increasing? F of x is increasing only on the interval from negative 1 to 3. And that will be answer D. And that does it for this problem.